everybody. Let's go ahead and get our green math notebook out. You're turning to the page that says multiply and divide decimals. Multiply decimals using the standard algorithm. Multiply decimals using the standard algorithm. This is the way that a lot of your parents have learned, so it should be pretty familiar. There's also a ton of videos out there that you can look at that will help you use this method to multiply decimals. Okay, so assuming you have your green notebook out and or your math notebook out and a pencil, then we're ready to go. Again, today we're going to find products of decimals, products meaning the answer to a multiplication problem, using the standard algorithm. So let's review a little bit. 143 times 6. Well, that gives me an answer or a product of 858. Let's go ahead and change that problem. 14 3/10 times 6. If you notice in this problem, I still have all the same digits, they're just in a different place value. When I do this math, I get 85 8/10. Our next problem to look at is 14 3/10 times 6/10. Again, I still have all the same digits, they're just in a different place value. If I multiply these numbers, I get an answer of 8 58/100. Here we have 14 3/10, and I'm multiplying by 6/100. Again, all the same digits, just in a different place value, and my product is 858 thousandths. Well, could you figure this one out without doing the work? 14 3/10 times 6 thousandths. Well, if I did the work, my answer would be 858 10,000ths. Hopefully at this point you're noticing a pattern. What do you notice about the placement of the decimal point in the product compared to the decimal points in the problem? So here we didn't have any decimal points and no decimal point in my answer. Here I had a decimal point and a decimal point. What are you noticing? Hopefully you're noticing this. Here I have one number total in my problem behind the decimal point. So I have one number total behind the decimal point in my answer. Same thing here. I have two numbers total behind the decimal point in my problem, and I have two numbers total behind the decimal point in my answer. 1, 2, 3 numbers total behind the decimal point in my problem, and 1, 2, 3 numbers behind the decimal point in my answer. 1, 2, 3, 4 numbers total behind the decimal point in my problem. 1, 2, 3, 4 numbers total behind the decimal point in my answer. So this is how you do the standard algorithm. We apply that very simple trick to this math problem. Okay, let's go ahead and start in our notebook. And we're going to find the product of 1 7/10 times 2 4/10. 1 7/10 times 2 4/10. Now I just want to be sure that we're all looking at this page here. See, we should have that problem on our notebook. Okay, so let's go ahead and set it up. I'm choosing to put it this way. Typically, the number with the bigger value goes on top, but it's really up to you. To me, it's just the digits. Okay, so let's look. How can I make 1 7/10 a whole number using multiplication? Well, this is from the recent lessons that we've done. I can make it a whole number if I multiply by 10. If I multiply by 10, that moves that decimal point one place value, and this would become a 17, which we can multiply 17 much easier than 1 7/10. How can I make 2 4/10 a whole number using multiplication? Same way, we multiply by 10, which moves that decimal point one place value over. So now my problem is 17 times 24, a problem I already know how to do. I can multiply these whole numbers and start there to find my product. So let's go ahead and do that. 4 times 7 gives me 28. 4 times 1 gives me 4. Add that 2. 4 plus 2 gives me 6. Let's use that placeholder 0. I would cross that off if I were you. Let's go ahead and do that. Cross that off. So we know that that's a placeholder 0. And then I'm crossing off this 2 at the top, so that way I know I've already added that 2. Let's go ahead and now multiply the 2 by each place value. 2 times 7 gives me 14. Here's my 1. Here's my 4. 2 times 1 gives me 2. And 2 plus that 1 gives me 3. Let's go ahead and add these down. 8 plus 0 is 8. 6 plus 4 is 10. 1 plus 3 is 4. Now, is this my final answer? No, of course not, because if I look back at my original problem, 1 and 7/10 times 2 and 4/10, that just wouldn't make sense. Let's say I rounded this to 2, I rounded this to 2. 2 times 2 is 4. 408 does not make sense. 2 times 2 gets nowhere close to 408. So instead, we need to think about it with these decimals, okay? So I moved the decimal out 1, 2 times total, 1, 2 times total. So now where will we put the decimal point in our product? Well, the decimal point will go behind the 4. See how I had one number behind the decimal point, 2 numbers behind the decimal point, total in my problem? Well, now I have 1, 2 numbers behind the decimal point, total in my answer. The total amount of places you move the decimal out of your problem equals the total amount you move it back into your problem. You can also think of it as how many numbers are behind the decimal total. That's how many total should be behind it in my answer. Okay? So let's go ahead and look at this next problem. Again, it's in your notebook. Find the product of 6/10 times 8/10. I chose to put the number with the greater value on top this time. And I have a total of 1, 2 digits behind the decimal total in my problem. Well, 8 times 6 gives me 48. Those are the base numbers I'm going to use. But I know that a number less than 1 times a number less than 1 is not going to give me 48. That just does not make mathematical sense. So let's go back and remember. I have 1, 2 numbers total behind the decimal point in my problem. So I'm going to have 2 numbers behind the decimal point in my answer. My final answer is 48 hundredths. Okay? Basically, all we're doing here is we're not writing out all the math. Oh, I take 8/10 and I multiply it by 10 to get 8. I take 6/10 and I multiply it by 10 to get 6. We already know that that's the math that we're doing, so we don't have to write that out every time. We can just follow this simple process. I have 1, 2 numbers behind the decimal point total in my problem. I have 1, 2 numbers behind the decimal point total in my answer. I already know the math behind that. Here I'm multiplying by 10. Here I'm multiplying by 10. When I put the decimal point back in, I divide by 10. I divide by 10. The math is there. The trick just cuts out the extra work. Okay, so at this time, I'd like for you to find a piece of paper or a whiteboard if you have it, and go ahead and try to solve this problem using the standard algorithm. Pause the video so that way that you have the time to work that out. Okay, all right, so let's go ahead and check our answer. Make sure you're checking your work with my work so that way we can find our mistakes. There's nothing wrong with making mistakes as long as we learn from them. Okay, so here's our problem, 3 and 8/10 times 9/10. I multiplied 38 and 9 and got 342. But I had 1, 2 numbers total behind the place behind the decimal point in my problem. So I have 2 numbers behind the decimal point in my answer. 1 plus 1 gives me a total of 2. So my final answer should have been 3 and 42 hundredths. Okay, make sure you're checking your work with what I have up there. Okay, mathematically, what are we doing when we move that decimal point in and out? Go ahead and answer aloud. No one's going to think you're crazy. Or, well, maybe they will. Okay, so we're multiplying and dividing by powers of 10. When I move the decimal out one place value, I'm multiplying by 10. When I move it back in one place value, I'm dividing by 10. So here, same idea. I move that place value out 2 times. I'm multiplying by 10, multiplying by 10, also known as multiplying by 100 to get 96. Here, I'm multiplying by 10 to get 71. I already know how to multiply whole numbers, so this is going to be so easy for me. 1 times 6 is 6. 1 times 9 is 9. I'm done with this place value here, so I'm going to go ahead and put my placeholder 0. Don't forget to cross that out, so that way we know it's the placeholder 0 and not just a 0 from when I multiplied. 7 times 6 gives me 42. 42. 7 times 9 gives me 63, and 63 plus this 4 gives me 67. Okay, go ahead and make sure you're copying that down, getting that down in your notes. Let's go ahead and add down. 6 plus 0 is 6. 9 plus 2 is 11. 1 plus 7 is 8. And 6 plus nothing is 6. Well, hopefully you're looking at this again. If I estimated this number, that's close to 1, and this is close to 7. 1 times 7 should give me 7. This 6,816 does not make mathematical sense for my original problem. So I'm going to make sure I account for those decimal points. So I had 1, 2, 3 total numbers behind the decimal point. So I'm going to have 1, 2, 3 total numbers. Again, 2 place values and 1 place value. So now I'm going to have 3 total numbers, 1, 2, 3, behind the decimal point in my product or answer. 6 and 816 thousandths is our answer to this problem. This is our product. Okay? So, again, we multiplied by 10, multiplied by 10. That's the same as multiplying by 100. We multiplied by 10. And so then we are dividing by 10, dividing by 10, dividing by 10. That's the math behind the trick. Here's a problem I would like for you to try on your whiteboard or on a piece of paper. Find the product. Find the answer to this multiplication problem. 35 hundredths times 15 hundredths. 35 hundredths times 15 hundredths. Go ahead and pause the video so that you have time to work this out. Okay, let's check our work. Make sure you're checking each piece of work to see if there are any mistakes. Remember, we learned from our mistakes. So here I had 1, 2, 3, 4 numbers behind the decimal point. So I have 1, 2, 3, 4 numbers behind the decimal point. This isn't something that we've talked about. I wonder how many of you rose to the challenge. I only had 3 numbers when I multiplied 35 and 15. So I knew 1, 2, 3, 4 numbers. There's nothing there. So I had to put a 0 there so I could clearly see the value of the number. Okay, this 0 is important because it's behind the decimal point. Anything that's going to be behind the decimal point, whether it's a 0 or an actual number that has value, is important. Okay, let's go ahead and do our closure. This is for you to check to see if you know what you have learned in this lesson. 1 2 tenths times 5 hundredths. 1 2 tenths times 5 hundredths. Go ahead and do this on your whiteboard or your piece of paper. Pause the video. Okay, let's see. Let's go over this problem. So, 1 and 2. Ooh, that's a beautiful 2. 1 and 2/10 times 5/100. 1 and 2/10 times 5/100. So I'm going to go ahead and rewrite this so that both numbers are whole numbers, because I just like to visualize it that way. So now I have 12 and 5. 12 times 5 gives me 60. Okay, so I'm coming back here. I have 60. How many numbers total are behind the decimal point in my problem? I have 1, 2, 3. So I'm going to have 1, 2, and 3 behind the decimal point in my answer. Okay, so hopefully this was just work for me to think it through. Hopefully your answer is 60 thousandths, also known as 6/100. Let's go ahead and try the second problem in our closure. 1 and 6/10 times 3 and 2/10. Go ahead and work that out now. Pause the video. Okay, let's go ahead and write that 3 and 2/10. Let's make that decimal point a little bigger. 3 and 2/10 times 1 and 6/10. Boo, boo, boo. I'm going to rewrite it because it just makes me visualize it a little better. 32 times 16. Again, still have all the digits that are there. Woo, I don't like that one. I still have all the digits that are there. It's just without the decimal points. So 6 times 2, that gives me 12. That's supposed to be a 1. Okay, 6 times 3 is 18. 18 plus 1 is 19. Placeholder 0. Cross that out. 1 times 2 is 2. 1 times 3 is 3. 2 plus 0 is 2. 9 plus 2 is 11. 1 plus 1 is 2 plus 3 is 5. So now I have 512 as digits to work with. I have a total of 1, 2 numbers behind the decimal point in my problem. So I'm going to have 1, 2 numbers behind the decimal point in my answer. My product should be 5 and 12/100. Thank you guys so much for watching the video and for working so hard. We're so proud of you guys. See you soon.